Hi friends, in this video let us solve a Fourier transform related question asked in GATE 2020 C paper. The question is the Fourier transform of the signal h of t is h of omega, which is equal to 2 cos omega sine 2 omega by omega. What is the value of h of 0? So what they given is h of omega they have given. What they ask is h of 0. H of 0 is nothing but h of t at t is equal to 0. How can we get h of t from h of omega? I have to take the inverse Fourier transform. So h of omega is equal to inverse Fourier transform. If you take inverse Fourier transform of h of omega, what we get is h of t. From h of t, we find h of 0 by substituting t is equal to 0. So what they have given is h of omega. H of omega is 2 cos omega sine 2 omega by omega. So 2 cos omega sine 2 omega is 2 cos A sine B. So this I can write as sine A plus B, sine A minus B. So sine A plus B is sine 2 plus 1, 3. So sine 3 omega. This denominator is common. Plus A minus B, sine 2 minus 1, 1. So sine omega by 2. Okay. So now I got h of omega. What I do is I have to get h of t. Now h of t, how can I get? I take inverse Fourier transform. So I know this is in sine omega by omega format. So it is more or less like a sinc. What is sinc? Sine theta by theta. So here sine 3 omega, if the denominator is also 3, then I can make it as sinc format. So why you make it as sinc format? Let me tell you. So sine 3 omega by omega, this I can write as sine 3 omega divided by 3, multiply and divide by 3. So it is 3 sine omega, 3 sine 3 omega divided by 3 omega. So it is sine theta by theta is sinc. So it is sinc theta. So it is 3 sinc 3 omega. Okay, so it's not 2, it's omega. Okay, fine. So why I made it in the form of sinc? I know for rectangular pulse, a rectangular t by tau, Fourier transformers a tau sinc omega tau by 2, right? So if I draw it in pictorial format, this is the pictorial representation of graphical representation. Minus tau by 2, this is a, right? Here it will be sinc function. Okay, right? So this you must know. Okay, now what I have is, so for rectangular pulse Fourier transform is sinc. So for sinc, the inverse Fourier will be rectangular. So what I have is 3 sinc 3 omega. So here I have this one. I have to get this one. So you see 3 sinc 3 omega. So a tau is sinc 3 omega. So 3 as per the problem. A tau is 3. Omega tau by 2 is, so tau by 2 is, you see, you can compare this one. Tau by 2 is 3. So tau by 2 is 3. This implies tau is equal to 6. Tau is equal to 6. Substitute this tau here. A is equal to 3 by 6, 1 by 2. So now for sinc 3 omega, what I get is, now if I draw graphical representation, this is minus tau by 2. Tau is equal to 6, so it will be minus 3 2 plus 3, right? Here A is 1 by 2. So it is the inverse Fourier transform of 3 sinc 3 omega. So like that, this is sine omega by omega. It is in the same format only. So sine omega by omega. So sine omega by omega, directly I can write as sinc omega, right? So sine omega by omega. So numerator, this point are both are same. So I can write as sinc omega, right? So what is tau by 2 in compared to general format? Tau by 2 is 1. Here coefficient is 1. So a tau is 1. So tau by 2 is 2. So tau by 2 is 1. This implies tau is equal to 2. A tau is 1. So A is equal to 1 by 2. So the inverse Fourier transform is minus tau by 2. So minus 1 2 plus 1. Here what I get is A is 1 by 2. So it is, let us assume h of t1. This is h of t2. Because it is h of omega. So this is h of omega. Let us assume this is h1 of omega. This is h2 of omega. For this inverse Fourier transform is h1 of t. This is h2 of t. So we got both. What I have to find is t at 0. So what is t at 0? This is t at 0. So this implies h1 of 0 is 1 by 2. This value. What about this? For this also h2 of 0. T at 0 is 1 by 2. So what is h of t? Sum of these two. H of t at 0. So h of t at t is equal to 0, which is equal to h of 0, which is given by 1 by 2 plus 1 by 2. It is 1. So the answer is 1. So option C is the right answer. Thank you.